Hi, we're back to talk about the law of sines. This is part 2 of the video on law of sines. And what we're going to do is we're going to start by going back to geometry and thinking about the triangle congruence theorems. One of the triangle congruence theorems, if you remember, is side, side, side. Another was angle, angle, side. You could prove two triangles are congruent if you can show that an angle, a side, and an angle are congruent. And you can also show that two triangles are congruent if you have a side, an angle, and a side. The one that you didn't get to talk about in geometry was this one, because that is not a theorem to prove that triangles are congruent. That is not a theorem to show triangles are congruent, and I'm going to show you why. Here we have the possible triangles in the SSA case. So consider a triangle in which you are given A, B, and angle A. Okay, there's several things that can happen. If A is obtuse, so if A is obtuse, angle A is obtuse, two things can happen. Either your side B that makes one of the sides of your angle, one of the adjacent sides, side B is longer than side A. And if that happens, there's no way that A is ever going to be able to be long enough to touch down here on this other side to make a triangle. So you would have no triangle. The other thing that can happen is that A is greater than B, in which case you have your angle A, you have side B, and side A would come down in exactly one place. So that would make one triangle. If A was equal to B, you also would not have a triangle, because if A is exactly the same size as B, it would come down right here and you wouldn't have a triangle. You would just have a segment laying on top of itself, so there would be no triangle. Now, this is where the tricky stuff starts to happen. If A is acute, if you're given a side, and an angle, and A is acute, there's three things that can happen. One thing is that side A is too short, and it's never going to be able to touch this side of the triangle. So no triangle would be formed. The other thing that can happen when A is less than B is that A can come straight down and just touch this side of the angle, which would make a right triangle. So you would have one triangle. Another thing that can happen is if A is larger than B, A would have to swing out this way and it can only touch in one place. So you'd have one triangle. This is where it gets a little more complicated. This is sometimes called the ambiguous case. And what's happening is you have an acute angle that you're given a side, and that second side is shorter than that first side that makes up the angle. And what can happen is the angle or the side can come down and it can touch and make a triangle right here. So I have this triangle. But here's the other thing. If it can swing in here and A is shorter than B, then the other thing that can happen is that A can also swing in this way. So now you also have this triangle. So you actually have two triangles that can be made with that given information. If you have an acute angle, a side, and then the next side is shorter. So we'll talk about all these different cases. We'll start with this one. We're going to solve a triangle. A is 130 degrees, side A is 24, and B is 17. So I'm going to make a picture of this. Okay, there's one side, and I need 130 degrees. So that's about there, so I'm not exactly right. And this is A. This is the 130 degrees. And it tells me that A is 15, so the side opposite this is 15, and B is 17. Somewhere down here, I have my vertice for B. I don't know where that is because I'm just given this angle, this side, and this side that was 15. So what's happening in this case is that A is smaller than B, and I have an obtuse angle. If you think about how big A is, if B is 17, A must be shorter than that. Now it doesn't matter how I try to move this side around. There is no way that if it's 15 that I'm ever going to be able to touch this other side. So no triangle can be formed here. So that's one thing that can happen. Now I want you to notice the angle was obtuse. The side, one of the sides that makes up part of that angle was 17, and the opposite side was shorter. Anytime that happens, you're never going to be able to have a triangle. So now let's try this one. This time I have an obtuse angle again. So here's my 130 degrees. I notice I'm making that long. I have no idea where my point is going to be on here to make a triangle. And then I have about 130 degrees. This is 130 degrees. That's A. B is 17. And A is 24. So A is longer than the 17. The only thing that can possibly happen here then is that I have one triangle. So that's 24. And this is B. So when I solve the triangle, that means I need to find all the angles, all the sides. And I'm going to use a law of sines on this because I have an angle and I have the side opposite. So the easiest way I can solve this is with the law of sines. So sine 130 over 24 is equal to sine B over 17. And I need to solve for B. B is an angle, so I'm going to have to use the inverse sine or the arc sine. I always like to think of it, if you're trying to find the arc sine, you're finding an angle, and then I know this is corny, but I think archangels, arcangle, so that's how I think of it. So I'm going to do a product of the means equals product of the extremes. So 17 times the sine of 130 is equal to 24 times the sine of B. And I want to divide both sides by 24. So when I solve for B now, I have the sine of B is equal to 17 sine 130 over 24. And in my calculator, this is what I'm going to type in. I'm going to do my arc sine. I'll have parentheses. 17 times sine 130. Make sure that you have parentheses around that 130. And then we're going to divide that by 24. Also, you want to make sure that your calculator is in degree mode because I'm talking about 130 degrees. I'm not in radians, I'm in degrees. And you end up with B is approximately 32.9 degrees. So I'm going to write this in, 32.9. And then magic is going to happen because all of this writing is going to erase. Just watch. It's amazing. And poof, that's all the information I have and all my work is gone. So I still need to find the measurement of angle C, and I also need to find this length of little c. So to find C, that's probably the easiest thing I can do because I'm just going to take 180